All right. Excuse me. This is 7-4. Properties of logarithms. Right, so our objective is to use all the different properties of logarithms to basically split them apart or put them back together. All the properties of logarithms come from properties of exponents, only because they're inverses of each other, they work backwards. And of course, logarithms and exponents have corresponding properties. So let's see what the properties are. So, for any positive number, mn and b cannot be equal to 1. So the base of these logarithms is not 1. The following properties apply. The product property means that if we add two logarithms together, we multiply whatever is inside of them. Or vice versa. If we're multiplying, we can split a logarithm apart by adding them together. The quotient property. The quotient property says that if I have a quotient, I subtract the two logarithms if I wish to split it apart. Or the opposite is also true. If I have subtraction, I can set this as one logarithm by division. Okay? So probably the most useful one, and the one that we'll use whenever we are solving logarithms next section, is the power properties, which says that if I have an exponent inside of a logarithm, I can take it out by flopping it down in the front, as you see right here. So exponents inside of logarithms become multiples in the front. Okay? Let's see how this works with some actual logarithms. So first, I see a subtraction here. Right? So I want to put these two logarithms together to form a single logarithm. My subtraction tells me I'm going to divide. So this turns into log base 4 of 32 over 2. Now, of course, we can simplify. 32 over 2 is log base 4 of 16. Now, we say to ourselves, remember how logarithms work, what power of 4 do I need to get to 16? The answer is 2. 4 squared is 16. And that is simplified as a single logarithm. Let's try the next one. First thing I notice is the two numbers out front. Let's combine them using the power property. So they both become exponents inside of the logarithm. So this turns into log base 2 of x to the 6th plus log base 2 of y to the 5th. The plus tells me that I'm going to multiply these two together. So it becomes log base 2, x to the 6th, y to the 5th. Okay. Next, we have a product again, a product property. So all we have to do is multiply the two logs together. So log base 4, 5 times 3 would be 15. X times x gives me x squared. And that's simplified together as one logarithm. Last one. We're going to do a power, which turns log base 4 of 6 squared minus log base 4 of 9. And then, because I see a subtraction, I'm going to do a quotient. So that turns into log base 4 of 6 squared, which is 36 over 9. This can simplify even further to log base 4. 36 divided by 9 is, of course, 4. And finally, what power do I raise 4 to get 4? The answer is 1. Okay? So that's putting logs together. We can also split them apart. So, my log here, I notice the 4, the x, and the 7. So I have 3 things. So this logarithm is going to comprise of 3 terms. So it would be log, no base, which means base 10, log 4, plus, because it's multiplied, log x, and then since the y is on the bottom, minus log of y. Next, Right? Two things going on here. I have two terms, so this splits into two different logarithms. Log base 9 of x to the 4th minus log base 9 of 729. Well, two things are happening here. First, I can use my power property to pull this 4 out. So that would give me 4 log base 9 of x minus, well, can this simplify at all? Well, 9 times 9 times 9 is 729. So this would be minus 3. And now that logarithm is simplified. So basically, with those three properties, these three properties right here, the product, the quotient, and the power property, we can change logarithms into one single logarithm or into multiple, depending on what we need to do. More often than not, when we get to equations, we are going to want to combine them into a single logarithm in order to solve them. Okay? So now let's see another useful property, which is called the change of base formula. A lot of calculators that we use, especially ones that are on your phone, do not have a button that looks like this, where I can put any logarithm base I want into this calculator button. Some of them only have this, only have the base 10. So what we can use is this change of base formula. Basically, it says that the base in B goes on the bottom, the log goes on top, and I can have any new base I want. So, what does this mean? An example, I can have log base 5 of 20, and if I wanted to work this out on a calculator that only had a base 10, I could do the log of 20 over the log of 5. And that would give me the same answer as a calculator that you could do any base logarithms. So even if you feel like you're at a disadvantage without a calculator with an open logarithm button like this, there are still ways to get to the answer. Or you could just figure it out by hand. So, how this helps us figure things out by hand is, I don't know off the top of my head what this would be. But I do notice that 81 and 27 share a common base. They both are powers of 3. So, if I change this to a log base 3 of 27 over a log base 3 of 81, I can now do this in my head. Because 3 times 3 times 3 is 27. That leaves me 3 at the top. 3 times 3 times 3 times 3 is 81. It leaves me 4 at the bottom. So using my change of base formula, I'm able to work this out. If I want to use a calculator, I do the same thing. I put in the log of 27 over the log of 81. It's going to be a little more messy. 1.43 over the log of 81 is going to be 1.90 about. But when I divide these, I'm still going to get about 0.75. 1.43 divided by 1.9 is going to be about 1.75. A whole bunch of more decimals going on this way, but we get about the same answer. Right? So let's try it with this one. Well, unfortunately, looking at this problem, I don't see a common base with either one of these, so I'm going to have to use my calculator. Assuming that I don't have a calculator with an open log button, I can change this to the log of 36 over the log of 5. So the log of 36 is going to equal 1.55 over the log of 5 is going to be 0.699. So 1.55 divided by that can equal about 2.22. And that's how we can use change of base to input a logarithm into a calculator that doesn't have the open base button. And that is it for 7-4, Properties of Logarithms. The most important takeaway from this is to make sure you remember these 3 properties because we will be using them when we solve logarithmic equations.